The role of silicon in technology, an in-depth exploration. Questioning the role of silicon in technology. How many times do we use technology in a single day? How many devices in our everyday lives would cease to function if a particular element were missing? From the smartphones in our pockets to the advanced supercomputers managing vast data centers, what common thread ties all these technological marvels together? The answer is silicon. But why is silicon, a seemingly simple and abundant element, so central to the growth and advancement of modern technology? Why has this particular element become the backbone of the information age, the digital revolution, and so much of the technology that we rely on today? Introduction to silicon. Silicon Si is a chemical element that has an atomic number of 14 on the periodic table. With an atomic mass of 28.085, it is a metalloid, meaning it has properties of both metals and non-metals. Silicon is the second most abundant element in Earth's crust, making up about 27.7% of its composition. It is commonly found in the form of silicon dioxide, SiO, which is a major component of sand and rocks. The significance of silicon, however, goes far beyond its abundance in the Earth's crust. This element has become indispensable to the development and functioning of modern technology, and in this article, we will delve deeper into why that is the case. Silicon and its role in technology. In the realm of technology, silicon is primarily known for its role in the production of semiconductors. Semiconductors are materials that have electrical conductivity between that of a conductor, such as copper, and an insulator, such as rubber. This unique property allows semiconductors to control the flow of electrical current, which is essential in the operation of electronic devices. At the heart of nearly every modern technological device, be it a smartphone, a laptop, a television, or even a microwave, are semiconductor components, the most common of which are transistors. Transistors are the building blocks of modern electronic devices, and function as tiny switches that control the flow of electricity in circuits. Without transistors, digital logic, data processing, and communication as we know them would not be possible. Silicon's exceptional ability to act as a semiconductor has made it the go-to material for creating transistors. Silicon's atomic structure is such that it can easily form bonds with other elements, allowing it to be precisely manipulated at the microscopic level. This ability to form high-purity crystals also makes it a versatile material for manufacturing integrated circuits, ICs, which are the heart of nearly every electronic device. In fact, when we speak of the Silicon Valley in California, we are referring to the birthplace of many of the world's leading semiconductor companies that have revolutionized technology. Why silicon is needed for technology. Silicon's need in technology stems from its unique properties and abundant availability. But why is it specifically chosen over other materials for technological applications? 1. Abundance and accessibility. Silicon is the second most abundant element in the Earth's crust. This means it is readily available, reducing the cost and difficulty of sourcing the raw materials needed for the development of technology. While other semiconductors like germanium or gallium are used in specific applications, silicon remains the most accessible and cost-effective choice for mass production. 2. Perfect semiconductor properties. Silicon has just the right characteristics to function as a semiconductor. In its pure form, it does not conduct electricity well, but by introducing small amounts of other elements, a process known as doping, silicon's electrical properties can be finely tuned. This makes it ideal for use in transistors and other semiconductor devices. 3. Thermal stability. Silicon has excellent thermal stability, which means that it can function effectively in a wide range of temperatures. It is able to withstand the heat generated by electrical components without deteriorating, making it ideal for applications in electronics where heat management is critical. 4. Durability and reliability. Silicon is durable and can be etched or patterned into intricate structures, making it perfect for use in integrated circuits and microchips. Its physical properties allow it to function reliably over long periods, which is critical for the longevity and performance of electronic devices. 5. Miniaturization. Over the decades, the ability to miniaturize electronic components has been one of the driving forces behind technological advancement. Silicon has been key in this regard because it can be processed into incredibly tiny components, enabling the development of smaller, faster, and more powerful devices. 6. Low cost. Silicon is relatively inexpensive to produce. Its widespread availability and the efficiency with which it can be processed make it an attractive option for the mass production of semiconductor components. 7. Electrical performance. The way silicon interacts with other materials makes it an ideal candidate for use in digital electronics. The ability to precisely control its conductivity allows for the creation of transistors that can handle complex tasks, such as switching between on and off states, a basic requirement for digital logic operations. Where is silicon found on Earth? As mentioned earlier, silicon is the second most abundant element in Earth's crust, found primarily in the form of silicon dioxide, SiO. This compound is abundant in sand, quartz and rocks, such as granite. In fact, the Earth's crust is composed of approximately 27.7 silicon by weight, with silicon dioxide being a common and abundant source. Silicon is extracted primarily from minerals such as quartz and sand. The process of obtaining silicon from these minerals involves heating them to high temperatures to separate silicon from oxygen, a process known as reduction. Once silicon is extracted, it can be purified to a very high degree, allowing it to be used in the manufacturing of semiconductors. Interestingly, silicon can also be found in trace amounts in some biological organisms, as it plays a role in the structural integrity of plants and certain microorganisms. However, its most significant application is in the technology sector, where it has become an indispensable resource for innovation. How much silicon is already in use? The amount of silicon in use today is staggering. Silicon-based technology has become deeply ingrained in nearly every aspect of modern life. According to industry reports, the global semiconductor industry is worth hundreds of billions of dollars, with the vast majority of semiconductor components being made from silicon. Silicon chips are used in everything from consumer electronics like smartphones, tablets and computers, to automotive systems, medical devices, and even household appliances. Virtually every modern electronic device contains silicon in some form, and this has led to an explosion in the demand for silicon-based components over the last several decades. The global production of silicon wafers, which are thin slices of silicon used in semiconductor manufacturing, has reached billions of units per year. In 2020 alone, more than 10 billion semiconductor devices were produced, most of which relied on silicon. In fact, it is estimated that the demand for silicon chips will only continue to rise as technology advances further, especially with the rise of the Internet of Things, IoT, artificial intelligence, AI, and other emerging technologies. Conclusion. Silicon is far more than just another element on the periodic table. Its unique combination of properties: abundance, semiconductor capability, thermal stability, durability, and low cost has made it the cornerstone of modern technology. From the earliest transistors to the latest smartphones, silicon has enabled the development of innovations that have transformed the way we live, work, and interact with the world. Silicon's ability to efficiently manage electrical conductivity has made it the preferred material for semiconductors, allowing the creation of tiny, fast and powerful transistors that form the backbone of digital electronics. Its importance is reflected in the fact that nearly every technological device, from consumer electronics to industrial machinery, relies on silicon in some form. As we look to the future, it is clear that silicon will continue to play a vital role in the ongoing evolution of technology. While new materials may emerge to complement or even replace silicon in some applications, it is likely that this humble element will remain at the heart of the digital age for years to come. The world is increasingly reliant on silicon, and its story is far from over. As long as technology continues to evolve, so too will the importance of this remarkable element.